Welcome to Lesson 7 of Unit 2 on graphing inequalities. In this lesson, you're going to be able to graph linear inequalities and graph absolute value inequalities. So let's talk a little bit about what a linear inequality is. A linear inequality is very similar to a linear equation, but instead of an equal sign, you have an inequality sign. So this inequality symbol you recognize as the less than or equal to, greater than or equal to, less than or greater than, and that's instead of an equal sign. If you have an equal sign, it's an equation. If you have an inequality sign, it's an inequality. The graph of an inequality for this specific inequality is shown at the right, and the graph includes all of the things that are in the shaded region. Any point that's in this shaded region satisfies that inequality. So every point in the shaded region satisfies the inequality. It'll give you a true statement. The graph of y equals, the equation y equals 2x plus 1, that is called the boundary of the region. Since the boundary, this is a solid line, it's drawn as a solid line to show that the points on the line also satisfy the inequality. However, if the inequality was just a less than instead of less than or equal to, then we would include that boundary as a dotted line, and they would not be, those points would not satisfy the inequality. Okay, so the boundary would be drawn as a dashed line. So let's take a look at some examples to figure out how to work these problems. So this example says graph this inequality. Since it's a greater than and it does not have an equal to, the boundary of the graph should be dotted or dashed, right? And it's going to be the boundary is going to be that line, and it's going to be dashed. Okay, so let's go ahead and figure out how to graph or how to draw the line here. And I think the easiest way to do that is to find the intercepts, right? So one of the techniques we've already learned is if you let x be 0, we can find the y-intercept. So if x is 0 right here, we have 3y equals 6, so y is equal to 2. And then likewise, we can plot the point where y is 0 to find the x-intercept. So if y is 0, we have 2x equals 6, and y is 3. Okay, so we could draw that line just by graphing those 2 points. 0, 2, and 3, 0 are right there, so you can get an idea of what your line's going to look like. And we said that's going to be a dashed line, so I could go ahead and draw that in here. Let me go ahead and pick some things in here to draw, and let's make that a red line. Match the color of my points here, and I want to go from here to here. So something like that. We could, whoops, we could draw that in there. Okay, so that's what my line's going to look like. It's going to go through those 2 points. See if I can extend that a little bit to make that look more accurate. There you go, something like that. Okay, so we've got the boundary line. Now we have to figure out which side is going to be shaded. So we're going to test a point. The easiest point to test is going to be 0, 0. And then if 0, 0 satisfies the inequality, then we will shade the side that contains 0, 0. If 0, 0 gives us a false statement, we'll shade the opposite side. So let's go ahead and plug in 0, 0. If we put in 0 for x and 0 for y, we get 0 is greater than 6. Is that a true statement? And that is not a true statement. That is false. Okay? So since it is false, we're going to shade the side opposite 0, 0, the side that does not contain 0, 0. So 0, 0 is right here. Okay? So we don't want that to be part of the solution, so we're going to shade the side above that. So there's a picture, and I have a little bit, this one's not accurate because the change the graph there is a different scale. So that's what that's going to look like. You have your y-intercepts just like we drew. It's a shaded boundary, or excuse me, a dashed boundary and shaded above and to the right. Well, what does an absolute value inequality look like? Well, it's very similar to graphing regular linear inequalities. So here's an example of an absolute value inequality. We're going to have a boundary that is dashed again, right? Because we have a less than sign. It's not equal to. We're going to test the same point, 0, 0. And so let's go ahead and just plug in some values for x and see what we get out for y. If I put in a negative 2 here, the absolute value of negative 2 is positive 2, so I get 2 plus 1, which is 3. If I plug in a negative 1, the absolute value of negative 1 is 1, and 1 plus 1 is 2. If I plug in a 0, I get out a 1. Plug in a 1, I get out a 2. Plug in a 2, I get out a 3. So there's some points that we could plot. If I plot those points, then I'm going to go ahead and test 0, 0. So if I put in 0 right here, if I plug in 0 is less than 0 plus 1, this gives me out a 0. So 0 is less than 0 plus 1, 0 less than 1. And that this time is a true statement. 0 is less than 1. So we want to shade the side that includes 0, 0 this time. Okay, so here's what our graph will look like. So we're going to have all of those points that we just talked about and shade the side that contains 0, 0. So all of the stuff underneath that V-shaped graph will satisfy that inequality. Here are two for you to try. Go ahead and make an XY chart or an XY table. Pick values for X and calculate what the values of Y would be. You can actually do problem number 1 by using intercepts and then probably pick XY values for number 2. And we can talk about this one when you come to class tomorrow. See you next time.